We are in an age of booming technological discoveries, yet who would have thought that some of our most complex advances were actually stolen from billion-year-old natural processes?
One such process is the spontaneous self-assembly of the phospholipid bilayer, which is now used to save lives by cutting-edge biotech companies. The key is polarity. In polar substances, one atom hoards the electrons. In water, this atom would be oxygen. It creates such an unequal distribution of electrons that it causes large partial charges, or dipoles, to form. In nonpolar molecules, such as fatty acids, the atoms share electrons pretty equally, meaning there are no partial charges, and therefore no dipoles. When you mix polar and nonpolar substances, such as vegetable oil and water, they don't combine very well, because polar molecules are much more attracted to themselves than nonpolar molecules.
Phospholipid bilayers work like the oil and water example. Each phospholipid has a polar head and a nonpolar fatty acid tail.
So, when a phospholipid is placed in water, the water, which is polar, is attracted to the polar head, but around the nonpolar tail, the water molecules are attracted to themselves, forming a sort of cage around the tail, which is highly ordered or structured.
However, this is not energetically favorable. Since the universe favors disorder, anytime something becomes more structured, less disordered, it takes a large input of energy. So if many phospholipids were placed into water, it would be energetically favorable for the polar heads to face outward, towards the water, and the nonpolar tails to be hidden from the water.
This structure is the phospholipid bilayer, 2 layers of phospholipids. It is such that there are no highly structured cages of water, meaning it takes the least amount of energy to form, and will therefore form the easiest.
This bilayer formation, along with its property of selective permeability, has given way to many incredible innovations, such as the oxygen microbubble. These microbubbles, while still under research, could potentially save thousands of lives every day.
In the case of a heart attack or damage to an airway, these microbubbles can deliver oxygen to your body through an injection.
Normally, a shot of oxygen into the bloodstream could kill a person, but these microbubbles are designed such that the oxygen diffuses out at a slow enough rate that no gas bubbles are formed in the bloodstream. Whether something happens playing sports, at school, or in a hospital, these microbubbles can be on hand, buying more time for CPR or other life-saving treatments. These microbubbles work much faster and are much more accessible than the large machines used today. Who would have thought that a process so old would be the key to the most cutting-edge medical research?